Hello everyone, welcome back to my channel. It's been a while. I took a short break from YouTube to focus on my studies, but now I'm back. If you are new to this channel, welcome. My name is Jason. I post coding tutorial videos just like this one on my channel. And if you enjoy this video, please consider subscribing. It'll mean a lot to me. For the past couple months, I have been receiving some requests to go through the other data analytics virtual experience program that is on InsideSherpa. Well, they're not called InsideSherpa anymore, they've actually rebranded. Now they're called Forage. But I have been receiving some requests, especially following the videos that I put out on the Quantium Data Analytics Virtual Experience Program. You guys seem to enjoy those videos a lot, so I thought today I'll take some time out to go through my notebook as well as my solution for yet another program on Forage. And more specifically, today we are going to look at the Data ANZ Program. And so if you're personally going through this program yourself, feel free to use this video as a guide and as a reference for you to complete the program. Otherwise, if you're just watching this for fun or if you're watching this for educational purposes, that's all good. I'll make sure to put a link in the video description, which will bring you to the Forage website, and there you'll find the instructions on how you can participate in the program as well as complete the program. So without further ado, let's now hop on to the official Forage website. So what we're looking at now is the Forage website for the Data ANZ program. And essentially this program involves two tasks. So task 1 is called Exploratory Data Analysis, and task 2 is called Predictive Analytics. And so in task 1, we are required to segment the dataset and draw unique insights, which include visualization of the transaction volume, as well as assess the effect of any outliers. And in task 2, in Predictive Analytics, we need to explore correlations between customer attributes, build a regression and a decision tree prediction model based on your findings. So what's going to happen in this video is I'll go through my notebook for task 1, and in the following video that I'm going to put out, I'll go through my notebook that's for task 2. So let's now view task 1. And while this loads up, I might just go through my GitHub just quickly. So you will be able to find this full notebook currently up on my GitHub. It should be on the Forage ANZ. Again, I'll put a link of this GitHub repo in the video description. So you will be able to find this. And in this video, I'll go through Forage ANZ task 1. And like I said, the following video, I'll go through Forage ANZ task 2. And another thing that I wanted to point out is you'll also find a notebook that has been written in R. So if you're more comfortable with using R, if that's what is more convenient for you, feel free to check this notebook out. So this notebook will be more suitable for people who prefer to use R to code up their data science project. So let's now go back to the Forage website. So this is task 1, Exploratory Data Analysis. And here's some background information. Let's just briefly go through this. So this task is based on a synthesized transaction dataset, which contains 3 months worth of transactions for 100 hypothetical customers. It contains purchases, recurring transactions, and salary transactions. And blah, 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 blah. You can go through this in your time. And more specifically, the tasks that we're given are as follows. So we need to start by doing some basic checks to make sure that we don't have any data issues. Next, we need to gather some interesting overall insights about the data. For example, what is the average transaction amount? How many transactions do customers make each month on average? And following that, we need to segment the dataset by transaction date and transaction time. Visualize transaction volume and spending over the course of an average day or average week. Consider the effect of any outliers that may distort your analysis. And finally, for a challenge, we need to draw insights from the location information that has been provided in the dataset. All of this will make more sense as we go through the notebook as well as the tasks. All right, so I think I've said what I've wanted to say. We can now move on to the actual notebook itself. So this is Jupyter Notebook. If you want to try Jupyter Notebook out, just do a quick Google search. You should be able to find some instructions how you can install it into your computer. All right, so in the first cell, we need to import the libraries that we will need for task 1. So we have pandas and numpy. So both of these libraries are for data wrangling and data manipulation. And following that, we have Seaborn and Matplotlib. So Seaborn and Matplotlib are data visualization libraries that are in Python. So what we're going to do is just go ahead and import those libraries. Following that, we need to read the dataset into our Jupyter notebook. And because this file is in an Excel format, we will require the read Excel function that is in pandas. And what we need to pass in is the working directory. So this is going to be different depending on where you've saved the file into your computer. This is my working directory. And then after that, we need to specify the name of the file. So this is an Excel format file. Again, I've already changed the name of the file, so this is going to be different depending on the name of your actual file. So we'll just bear that in mind. And what we're going to do next is just have a look at the first 5 rows. So basically the rows in this dataset are the historical transactions that have been made by ANZ customers. And the columns or features are characteristics that are used to describe these transactions. For example, what is the name of the customer that has made this particular transaction, what is their age, where do they live, what is the transaction amount, at what time did they make that transaction, and so on and so forth. And so if you're unfamiliar, ANZ is one of the big 4 banks here in Australia, and basically the overall goal of this program, I suppose, is to go through these historical transactions, these past transactions that have been made by their customers, in efforts to draw some unique insights to better understand their customers as well as their purchasing behavior. All right, so I've left a little note here which says that this dataset contains 3 months worth of transactions for 100 customers, which includes purchases, recurring transactions, and salary transactions. So I've simply copy and pasted this from the instructions that we've been given in the Forage page. And what we're going to do next is just have a look at all the columns that are present in our dataset. So what I've done here is use a pandas data frame. So this is a pandas data frame, and basically just have a look at all the columns that we have. So recall in our first column we have status, and in our final column we have movement, and all of these are the columns that are in between. So I wouldn't worry too much about these columns because later on we'll go through each column individually and examine what they mean. And next we have data.shape. So this allows us to check the number of rows as well as the number of columns in the dataset. So we have 12,043 rows as well as 23 columns for this particular dataset. All right, cool. Once we've done that, we can now move on to basic checks, which is the first task that's required in this particular task. So for basic checks, I essentially want to check for 3 things. So the first one is we want to make sure that there are 100 unique customers. And next thing that we're going to check is we want to make sure that each row corresponds to a unique transactions, or in other words, we don't want any duplicated transactions. And last but not least, we want to make sure that we have 3 months worth of data. Let's now go through each task individually. So the way we will go about checking whether or not we have 100 unique customers is actually having a look at the customer ID column. And the function that we're going to use specifically is the n unique function. So this is going to tell us the number of unique customer IDs in the dataset. So here we can see that we have 100 unique customer IDs. That also tells us that we have 100 unique customers. So that's check. Next, we want to check that each row corresponds to a unique transaction. And the way we would do that is making sure that we have the same number of unique transaction IDs as they are the number of rows in the dataset. And so here we have the number of rows in the dataset, we have 12,043. And as for the number of unique transaction IDs, we also have 12,043. And so this is my way of showing that each row corresponds to a single transaction and there is no duplicated transactions. All right, so last but not least, we want to check for the period of our transactions. So we've been told that we have 3 months worth of transaction. Let's now make sure that that is the case. So what we can use is the describe function, and we will go ahead and apply this describe function to the date column specifically. And the describe function will basically tell us the count, so how many dates are there, the number of unique dates, and so on and so forth. So here we can see that we do indeed have 3 months worth of data. So because the first date that we have in the date column is actually the 1st of August, and the last date that we have is the 31st of October. So the very last day of October. So we have August, September, and October. So those are 3 months. And so the note that I have here says that we do indeed have 3 months worth of data starting from the 1st of August 2018 to the 31st of October 2018. However, because in August we have 31 days, and in September we have 30 days, and in October we also have 31 days. So altogether we should have 92 days. And because we only have 91 unique days here, suggests that there is one date that's missing. And we can figure out which day that is missing by doing this. So first, what I've done is create a date range in pandas. Basically, create a date range that starts from the 1st of August and ending on the 31st of October. And what I did next is actually use the difference function and pass in our date column of our data set. And what this does is it'll spit out the date that is missing in our date range. And in our case, the date that's missing is the 16th of August, 2018. All right, so once we've done that, we will now move on to non-null count and data types. And the function to pay attention to here is the .info function. So .info tells us two things, with the number of missing values in a particular column, as well as the data type of a particular column. All right, so next we will look at missing values. So what I've done here is create a variable called missing, and I've used isNull_sum. This is going to create the number of missing values for each column. And in this next line of code is to only show me the columns where there is a missing value, which explains the missing greater than 0. So if a column doesn't have any missing values, just exclude them. I only want to focus on the columns that have missing values. And next, what I've done is also work out the missing percentage. So what is the percentage of missing values in that particular column? And the way we would do that is take the number of missing values, divide by the number of rows in that data set, and multiply by 100. So that'll give you a percentage. And putting everything together in a pandas data frame. This is the output of what we've just did. So here we can see that we have 1, 2, 3, 4, 5, 6, 7. We have 7 columns with missing values. And in the first column here, we can see that these are the number of missing values in each column, as well as their corresponding percentages. So the first 2 columns, so these two have the highest percentage, so 93%. And the remaining ones we have about 36%. And so here I've left a comment saying that both BPay biller code and merchant code, so these 2 columns here, contain a significant number of missing values at 93%, so that's quite severe. So we will need to deal with these missing values later on, but for now we will move on to summary statistics for the numerical columns in the dataset. So in terms of descriptive statistics, we will use the describe function, which we've already saw from early on. So basically, what we're trying to do here is look at the numerical variables. And the numerical variables in our dataset are these 5 columns. So card present flag, merchant code, balance, age, as well as amount. And so describe function is a good way for us to observe any anomalies in the numerical variables. For example, we can check that if the age and the amount column contain any negative values, because age shouldn't be negative and amount shouldn't be negative as well. And another thing that we can sort of look out for is to make sure that we don't have, for example, a customer that has an age of 150, because that doesn't make sense. So what I'm trying to say here is that the describe function is particularly useful for us to examine the numerical variables and making sure that all the distribution of values are consistent with our expectations, and making sure that we don't see any anomalies. All right, it also provides us, the describe function, it also provides us with an overview of the basic statistics for the amount column. However, we do not know the breakdown of the transaction amounts. So what I mean by that is we have a good sense of what the average is, we know what the minimum value is, we won't know what the maximum value is, but we don't know the actual breakdown of these transactions. So that will require a further analysis on our part to sort of break down this transaction by categories and sort of examine that later on. We can also see a huge spread between the maximum and minimum value both in the balance column as well as the amount column. So for example, in the balance column, we have a minimum of 24 cents and a maximum upwards of 260,000. So it's quite a huge difference. And the same thing goes for the amount column. So in the amount column, we have a minimum of 10 cents maximum of almost 9,000. So we will look into this later on, so I wouldn't worry too much about it. Alright, so now we will move on to exploratory data analysis, and in this section we will go through each column individually, and not only understand the meaning behind each of these columns, but also examine the distribution of values in each column in efforts to sort of understand what they represent, but more importantly how they fit into the overall goal of us trying to uncover the insights about our customers as well as their transactional behavior. So we'll first start off with some categorical variables, and let's now start with our first categorical variable called status. Alright, so what I've done here is apply the value counts function to the status column, and so here we can see that we have almost 8,000 rows with the value authorized, and about 4,000 rows with posted. So what this means, I guess authorized means that the transaction has already been approved, and meanwhile posted means that a particular transaction is still in the process of being verified and being processed. Next we have card present flag. Again, we're going to apply the value counts function, and I've also set the drop any argument to false. So what this means is show me any missing values if there is any present in that particular column. So for the card present flag column, we can see that we have around 6,000 rows with the value of 1. We have 4,000 missing values. So NaN stands for not in number, so these are missing values that are present in that column, and we have about 1,500 rows with the value of 0. So I initially didn't know what card present flag was. I had to do some googling, but I did manage to find this article by Square, which I encourage you to check out. So I've included a link here on my notebook, which will bring you to the Square website. So basically you can go through this blog post yourself, which goes into detail what card not present transactions are. But basically, in summary, these are transactions that occur when neither the cardholder nor the credit card is physically present at the time of the transaction. So it's most common for orders that happen remotely, either via the phone or over the internet or mail. Let's now move on to the next categorical variable that we have. So the next one that we have is currency, and after applying the value counts function, we can see that all of the transactions, so all 12,043 rows are actually in AUD, and so the comment that I've left here says that all transactions are made in the Australian dollars. So we can potentially drop this column because it is unnecessary, because it does not provide us with any additional information, considering the fact that every single row are transactions that have been done in the Australian dollars. Let's now move on to the next one. We have longitude and latitude. So this one is the coordinate, and so to give you an idea of what the longitude and latitude column looks like, these are the first 5 rows, and so these are the coordinates where the transactions were made. And next we have transaction descriptions, or in other words, the type of transactions. And again, similarly, we can use the value counts function just to have a look. And what I've done here, just to make our analysis easier, is actually use count plot. This is one of the visualization in the Seaborn library. And so basically count plot shows us the value counts for each of the unique values in the transaction description column. And so here we can clearly see that most of the transactions that have been made are post and sales post. And we have the least number of phone bank transactions. So this is just a good way for us to sort of visualize the distribution of the categories for different types of transactions. And so these are the descriptions for each transactions. Transactions mostly consist of sales payment. So so those are the first 2 columns that we have here. So the blue and the orange one. Also, this might explain the missing values in the merchant columns, because not all transactions are purchases of goods and services from merchants. Because from here we can see that there are certain transactions that are simply related to pay and salary payments. So those transactions don't involve merchants. Those are just payments that are paid out to employees. So that might explain the reason why we have some missing values in the merchant column. But we will have a look at this, and we will validate whether or not that's true as we go through this notebook later on. What I've done here next is actually work out the average transaction amount. broken down into each category. So here I've selected the two columns that I want to look at. So the first column is transaction description, and the next column is amount. And once we've selected those two columns, we want to group those transactions by their description, so by categories, and apply the mean function to the amount. So we want to work out what the average transaction amount is for each category. And finally, we have sort values. So what this does is pretty much just arrange the average transaction amount from highest to lowest. And as a result of all that, we get this particular data frame. So here we can see that pay and salary has the highest transaction amount. And what we can actually do is also similar to count plot. We can use this time called a bar plot for us to visualize this. So this is a lot easier for us to visualize in comparison to what we have in the table. So here we can clearly see that pay and salary is significantly higher than all the other categories. And that makes sense because salary payments are usually higher because these are the salaries that people take home, and they should be overwhelmingly bigger than, for example, the purchase amount that you make at a cafe or at a grocery store or something like that. So it makes sense that we see something like this. So pay and salary essentially has the largest average transaction amount, and this seems quite logical. All right, so following that we have gender. So this is quite straightforward. We have about around 6,000 customers that are male, and about 5.7 thousand customers that are female. And so this is just a simple count plot. So more male customers than female customers. And similar to how we've broken down the average transaction amount by categories, this is my way of breaking down the average transaction amount by gender. So here we can see that male has a higher average transaction amount than females. All right, moving on to our next categorical column called merchant suburb. We're just repeating the process now. So we're applying the value counts function to the merchant suburb column. So here we can see that we have around 4,000 missing values. And we can see here both Melbourne and Sydney have around 200 transactions. And quite similar to merchant suburb, the next column that we have is called merchant state. And again, apply value counts to the merchant state column. This is what we have, around 4,000 missing values and 2,000 transactions for New South Wales and Victoria. And we can also use a count plot for us to better visualize this. So most of the transactions actually come from these two states, so both New South Wales and Victoria. And we have the least for Tasmania and the ACT. All right, so similar to how we've broken down the average transaction amount by categories, we can also do the same for each state. And this is the result of that. So here we can see that ACT has the highest average transaction volume, although here we can notice that the variance is quite large. And next we have the extraction column. And so let's have a look at the first 5 rows of the extraction columns. So what we can do is simply cross-reference this with the existing date column that we have in the data frame. So here, for example, in the first row, we can see that the transactions made on the 1st of August. And obviously, the date matches up with the date column. And following that, we have the actual time at which those transactions occur. So here what I've done is I've written a note. Since we already have an existing date column, we can potentially extract only the time component. So that's the hour, minute, and second component of the extraction column, and just get rid of the rest because we already have an existing date column in our data frame, so we don't need this information. But we will deal with this later on. Let's now move on to country. Again, value counts applied to the country column. We can see that all the transactions are made in Australia, and therefore we can consider dropping this column since it does not provide us with any additional information. So this is quite similar to the currency column that we saw early on. So because all the transactions are made in Australia, we can simply just drop this column because it does not provide us with any useful information. Next we have merchant longitude and latitude. So this is another column which represents the coordinates. but this time instead of the coordinates for customers, we have the coordinates for the merchants. And last but not least, we have our final categorical variable called movement. So this is basically just a label for payments that have been made with either a debit card or a credit card. So here we can see that most of the transactions are actually done via a debit card, and we have about 900 transactions made in credit card. And using a count plot, this clearly shows us that most of the transactions actually are coming from debit card, and we only have a small number of transactions that are done using a credit card. But if we actually work out what the average transaction amount is for both debit card and credit card, we can see that the transaction amount for credit card is overwhelmingly bigger than debit card. And this makes sense because if we think about credit card, we usually use credit card for bigger purchases. For example, if we're trying to buy appliances or TV, so these things are usually more expensive, and people typically use credit card for these sort of transactions, whereas debit card is typically associated with more daily uses. So for example, if you go to a cafe to buy a coffee, you probably use a debit card, or for your daily grocery runs, you will use a debit card. So it makes sense that we see an average transaction amount that's higher for credit card transactions than debit card transactions. So this makes sense. So now that we're done with all the categorical variables, we can move on to numerical variables. So starting off with the balance column, we can use a displot to visualize the distribution of the balance. And so this is the result of this plot. We can see that most of the transactions actually hover around, we can see that most of the balance actually hover around this early value of maybe 1,000. And we do have quite a long tail going upwards of 250,000. And another way that we can use this, if you don't like to use this plot, we can use a box plot, but basically this provides us with the same information as well. And so here, the comment that I've made is that the distribution of the balance feature has quite a long tail. And next we have the age of the customers. So similarly, we can use a displot to visualize the distribution. So here we can see that most of the customers actually belong in the 20 to 25 age bracket. So this is where we see this peak here, and we also see another peak here around the 40-year-old age mark. All right, moving on. Next we have transaction amount. So this is quite similar to the balance column in the sense that we have most of the values at the beginning and quite a long tail going to the right. All right, so that wraps our exploratory data analysis. We can now move on to what is called feature engineering. So basically in this section, we will focus on a few things. So we want to focus on dropping unwanted columns. We will deal with missing values that we've located early on. And then finally, we will come up with some additional features that will make our data analysis more detailed and more robust. So starting with dropping unwanted columns. So these are columns that do not provide us with any useful or additional information. And as I've mentioned early on, those two columns are currency and country. And because all the transactions are done in AUD and all the transactions are done in Australia, we can simply just drop those two columns. So before dropping the columns, we have 23 columns, and after dropping those two columns, we have 21 columns that are left. All right, moving on. Now we will deal with the missing values. And so this is the data frame that we saw from early on. Let's investigate if there's a reason behind these missing values. So recall that not all the transactions are purchases related, and that might explain the missing values that we see in these columns. So merchant ID, merchant suburb, merchant state, and merchant coordinates. And because salary payments, like I said, don't involve a merchant, don't involve an exchange of goods and services, that might explain the missing values that are present in these columns. And the way we would actually go about this is use the look function that's in Pandas. So if you're unfamiliar with look, I highly encourage you to check out a tutorial video that I put out on the look function. I'll put a link somewhere up there, so make sure you go check it out. And so what's going to happen here is we will use the look function to filter out transactions that are not purchases related. So here we want to, and so here we've specified that we don't want any transactions that are from sales POS. We also don't want any transactions that are from POS. And then we can go ahead and compute the missing values in our non-sales variable. And so here we can see that we have the same number of missing values in these 5 columns, so 4,326, and that corresponds exactly to the missing values here. So what that means is all of the missing values that are coming from these 5 columns are actually from transactions that are non-sales related. So that confirms our hypothesis, or in other words, the reason why those missing values exist is because those transactions simply don't involve a merchant, and so it makes sense that we see some missing values in those 5 columns. And so the note that I've written down here is states that, as expected, missing values in the following columns all originate from non-purchasers transactions. And therefore, it's safe for us to proceed to fill these missing values with non-applicable. So what I've done here is actually create a list of the 5 columns that we want to fill, and basically just go through each column in that list. And if we find a row with missing values, simply fill that row with NA. And we can check once we've done that. Now the only 2 columns remaining with missing values are the merchant code and BPay biller code column. And because these 2 remaining columns are severely missing, so like I said from early on, about 93% of the columns missing, we will proceed to drop these 2 columns entirely from the data frame. And again, using the drop function, we will proceed to drop these 2 columns. And now make sure that we don't have any more missing values in our data frame. All right, cool. So let's now move on to creating features. So we want to create features for month, day of week, and hour. So the goal behind this is so that we can analyze our transactions across a period of time. We can look at transactions that happen at a certain day of the week. But before we do that, let's now work out the daily transaction volume for each day. And the way we do this is via the group by function. So we want to group all the transactions by date and then sum all the transaction amount up. So basically, this data frame represents the transaction volume for each date. And so, for example, the first row, we have the 1st of August, the 2nd of August, and so on and so forth. And next, what we're going to do is use a line plot to visualize our time series. And so here we have the 1st day of August, which is the 1st day of our transactions. And we have those transactions ending on the last day, the final day of October. So it does appear that we see this cyclical pattern that's going on with the transaction volume over the 3-month period. And essentially what I've done is written some hypotheses for this occurrence. And the first hypothesis that I have is that salaries are paid out only on certain days of the week. And what I mean by that is because salary payments have such a high transaction amount, and if they're only paid out on certain days of the week, that might cause a certain pattern that we observe in this time series plot that we see here. And another hypothesis that I have is that people might tend to spend more during the weekends, go out for shopping, or they go hang out with their friends. But essentially those 2 are my hypotheses behind why we see this pattern that's going on in our time series plot. And therefore, to motivate this analysis, for us to check if this hypothesis holds true, we will create 3 additional features from both the date and the extraction columns. And those 3 new features that we will create are the month, day of week, as well as the hour. So let's start off with month and day of week. So this is quite straightforward. Because we already have an existing date column, we can simply use date time index. This is another function in pandas. We can pass in our date column and simply just extract the month out of the date column and put that new information into a new column called month. And essentially we're just going to repeat the process for day of week. So again, date time index function, pass in our date column and extract the day of week out of the date column and put it into a new column called day of week. And so this is the result of what we just did. So now we have 2 new columns, one called month and one called day of week. And so it does appear that the month makes sense because all of the transactions in the first 5 columns are from August, and we have the month of August for the first 5 rows. And the 2 in the day of week column simply means that it's Tuesday for this date. You can check this date on Google to just make sure that that is the case, but I haven't actually made that check. I've just took it as it is. But in any event, let's now move on to the hour column that we want to create. But before we do that, let's now update the extraction column that we have, which contains the timestamp. And so these are the first 5 rows for the extraction column. And like I said from before, because we already have an existing date column, we will not require an extra date in the extraction column. So what I'll do in this section is actually get rid of the date as well as all the zeros at the end. So what we want is only the hour, the minute, and the second values in the extraction column, and everything else we want to get rid of them. And how do we do that? So the way we do that is via a function called split. If you're unfamiliar with split, it's quite easy. I'll briefly go through this, but if you're still unsure, just do a quick Google search. So what's going to happen now is I want to split each timestamp where the letter T is. So this is our letter T. So what split's going to do is it'll split this particular timestamp into one component, followed by the T, followed by the second component. And because what we want is in the second component, so we need to tell Python that we only want the second component, which is what I've done here with the number 1. Because Python index starts with a 0, so what we want is actually specify the number 1. So that will tell Python that we actually want the second component. And once we get the second component, we want to do another split, this time where the full stop is. So split the second component into our first component, followed by a full stop, followed by a second component. This time around, we want the first component, right? And so therefore, we need to specify the value of 0. So that's essentially what's happening behind the scenes. And so once we've covered all the timestamps in each of the rows, this is what we have at the end. So essentially now we're only left with the hour, the minute, and the second, which is exactly what we want. So in order for us to create our new hour feature, essentially what we want is only the first number that we have in the extraction column. And so unsurprisingly, we want to use another split. So we want to split where the semicolon is and essentially just take the first component of the split, which is represented by the number 0 here, and put all the hour information into a new column called hour. And so this is the result. So we've successfully taken out the hour and put it into a new column. And finally, because the hour is currently an object, we want to turn it into a number. And so the function that we want to use here is called toNumeric, and simply pass in our hour column. So before it was an object, and after applying the toNumeric function, we have an int 64. All right, so we finally reached the final part of this notebook. The final part is what I call a deep dive. So what this means is now that our data frame is in a much better shape, and now that we have new features to work with, that is the month, the day of week, as well as the hour features, we can now do a deep dive and see if we can gather any interesting insights about our customers' transactional behavior. And so let's have a look at the data frame again. So this is our data frame. And if we scroll all the way to the right, we can see the 3 new columns that we just created. So month, day of week, and hour. All right, so first thing that we want to do is look at purchases amount as well as the overall amount. So in this first cell here, what I've done is again use the log function and filter out transactions that were purchases related. And so we do observe quite a peak at the very beginning, and the distribution sort of levels off and has quite a long tail. So what we want to compare the purchases transaction amount with is the overall transaction amount. So the overall transaction amount would include stuff like salary payments and bank transfers and so on and so forth. And again, we can use this plot to visualize our overall transaction amount. And so here my note says that the variance in the overall transaction amount is much higher than the purchases transaction due to the inclusion of salary payments. So as we can see here in the overall transaction amount, we can see that the standard deviation is about 592. However, for the purchases amount, it's only 150. So it's quite a drastic difference. And the reason behind this difference is due to the inclusion of salary payments, and because we know that salary payments have quite a huge difference, and the amount is also quite large, that has played a role in sort of affecting the overall transaction amount having quite a larger variance in comparison to the purchases amount. All right, so next what we're going to do is work out the transaction volume per customer, and more specifically, we want to look at the monthly volume for each customer. And the way we do that is quite unsurprisingly, we need to use the group by function again. We need to group the data frame by customer ID and then sum up the transaction amount. The reason why we've divided by 3 is because we have 3 months worth of transactions, and in order for us to work out the monthly transaction volume, we need to divide by 3. That will sort of give us an average of the transaction volume for each month. All right, so in this data frame, we can see that each row represents a single customer, as well as their respective customer IDs, as well as their monthly transaction volume. And we can use this plot to visualize this monthly transaction volume. All right, so last but not least, we want to analyze the trend in the transaction volume over time. So this particular task is going to involve the 3 features that we've created. So month, day of week, and hour. So firstly, this is the average transaction volume by month. So here we can see that October has the highest average transaction volume in comparison to August and September. Next, what we want to compute is the average daily volume. So similar to how we've grouped our data frame by customer ID, here we want to group our data frame by each day of the week. And then what we want to do is apply the mean function to the amount column. So that's going to allow us to work out the average daily transaction volume. So this data frame is a perfect illustration of that. So down the rows, we have each day of the week, as well as their corresponding daily transaction volume. And then we can use a line plot to sort of visualize this. So here we can see that Sunday, we have the highest average transaction volume. And on the other hand, Friday and Saturday, we have the lowest record of transaction volume. So let's now see a breakdown of these transactions by the types of categories to just sort of figure out if there's a reason why Friday and Saturday we sort of experience the lowest transaction volume. And to simplify the categories a little bit further, I will reduce the number of categories down to 3 categories. So the first category is salary, and next we have purchases, and last I've put everything else under the category others. So this is the existing categories that we have. So here we have 1, 2, 3, 4, 5, 6 categories. So what I will do now is get rid of 3 categories and only have 3 categories left for us to analyze. And so what I've done here is sort of relabel everything. So I've relabeled pay/salary as just salary. And if a certain transaction is sales POS or POS, I've labeled it as purchase. And everything else is simply called others. And so this is the result of what I've just did. So I've relabeled all the different categories. And then we can use this new category that we just created and have a look at the trend, the average transaction volume across each day of the week. And quite immediately, we can see that both Friday and Saturday, we don't have any green bars that are attached to them. And the green bars are actually salary payments. And so the note that I've written down here states that no salaries were paid on Friday and Saturday. Therefore, that explains the lower average transaction volume that we observe on both of those days. And what I mean by that is that because salary payments have such a high transaction amount, if they are not paid out on both of those days, that will dramatically bring down the average transaction volume for both of those days. And that's exactly what we've observed in our line plot up here. All right, so now that we've done daily volume, we can take a step further and do hourly volume. And again, we want to group our data frame by hour, and then simply apply the mean function to the amount column to get an average transaction volume. All right, so this is our data frame. So down the rows, we have the transaction volume for each of the hour during the day. And then we can use a line plot to visualize this. And here we can see that the highest transactions actually occur during the midday, so around the about the 12 p.m. mark. And we also have another spike here that's during the late afternoon. Let's now see a breakdown of these transactions by their categories. So from this chart, we can observe 2 things. The first one is that we can see that salaries are only paid out on certain hours during the day, from 11 a.m. till 5 p.m. And hours that fall outside of that, we don't see any green bars, which tells us that there are no salary payments during those hours. And the second thing that we can see here is that transaction volumes are very low during the first couple hours of the day, so starting from 12 a.m., 1 a.m. and onwards. And we can see a peak here that occurs at 9 a.m. and more specifically the transactions that were purchases related. So this might be attributed to the fact that people might go to work around the 9 a.m. mark and spend some money on coffee or breakfast while they're on their way. So that might sort of explain what we see here. So to wrap up task 1, our final task involves calculating the distance between the customers and the merchants. I actually haven't done this task personally, and so I've left this as a homework for you guys to complete. But essentially what you can do is you can refer to this particular library in Python called haveAssign. So in this library, you can find a function that can help you calculate the distance between the 2 points by simply passing the longitude and latitude. So do let me know how you go with that final task, but otherwise task 1 is officially done. So what we want to do now finally is just simply save the dataset that we have into a computer so that when we move on to task 2, we can use the same dataset again for further analysis. Alright, so that's a wrap for task 1. I hope you guys found this video helpful. If you enjoyed this video, please drop a like on the video, as well as share it with your friends who are considering doing this program. Otherwise, take care, keep learning, and I look forward to seeing you in my next video where I'll go through task 2 of the Data ANZ program. Bye.